3 minutes prior, the Webb telescope just found a tenable green planet, one of the most fascinating discoveries to date. Could this mean there's another universe out there, with lush green scenes like our own? If that sounds like something new, prepare yourself for some enormous energy. The Webb telescope has made a surprising revelation: a livable green planet. Yes, you heard it right. This weighty finding opens up a vast expanse of possibilities and energizes our imagination about the existence of extraterrestrial life. Join us on a journey beyond anything we could ever imagine as we delve into the surprising disclosure that promises to reshape our understanding of the universe. Are we alone in the universe? The answer might lie in this freshly discovered divine haven. But first, here's something small you can do for us. If you're new to the channel, don't forget to hit the subscribe button. Also, press the bell icon right next to it to stay updated with more phenomenal videos. Now back to the point. Since its launch in December 2021, the James Webb Space Telescope has made significant strides in exploring the universe. One of its outstanding discoveries is the identification of an Earth-sized planet, marking a major milestone in its mission. The telescope's primary focus has been unraveling the mysteries of the universe by uncovering previously unknown stars and planets. In this pursuit, the James Webb Telescope has proven to be incredibly effective in probing the potential for life on newly discovered planets. Recently, the telescope made a historic revelation: a potentially habitable, Earth-sized planet that could be a viable candidate for human habitation. Researchers are particularly intrigued by this celestial body and are eager to learn more about its characteristics. How did the James Webb Space Telescope manage to pinpoint this Earth-like planet, and what makes it stand out? These questions captivate the academic community as they delve into the specifics of what makes this planet unique and why it's considered a promising prospect for future Earth settlement. The James Webb Space Telescope, otherwise known as Webb, is an incredibly advanced tool for exploring the vast expanse of our universe. Unlike its predecessor, the Hubble Space Telescope, Webb is equipped with cutting-edge instruments, including high-resolution and exceptional sensitivity. These capabilities allow it to observe objects that are too old, distant, or faint for Hubble. Webb relies on infrared astronomy to explore various aspects of astrophysics and cosmology. Its primary mission includes observing the first stars, studying the formation of early galaxies, and providing detailed descriptions of potentially habitable exoplanets. One star that has captured the attention of the scientific community is WASP-96, a yellow dwarf star. This star has generated excitement due to its potential for human habitability. While resembling our Sun, WASP-96 differs by being cooler and older. Surprisingly, it is situated around 1,150 light-years away in the southern constellation known as Phoenix. This main-sequence star is known to host at least one exoplanet, adding to the fascinating discoveries made possible by the impressive capabilities of the James Webb Space Telescope. Let us now explore the details surrounding WASP-96 and other intriguing celestial phenomena unveiled by Webb. One of the most notable stars in the sky is WASP-96b. This celestial object only came into our awareness in 2013 when it was detected through the efforts of the Wide-Angle Search for Planets, WASP. WASP is not just a single entity, it's a global consortium made up of various academic organizations. Together, these groups have come together to conduct an extensive search for exoplanets using a method called transit photometry. The WASP project utilizes a network of automated telescopes designed to survey the entire sky simultaneously. These telescopes steadily observe thousands of stars with apparent visual magnitudes ranging from around 7 to 13 to cover both the northern and southern hemispheres. The program operates two continuously running automated observatories. The first, known as SuperWASP North, is located at the Roque de los Muchachos Observatory on La Palma Island in the Canaries. The second, SuperWASP South, is situated at the South African Astronomical Observatory in South Africa. This collaborative effort involves the Isaac Newton Group, the Instituto de Astrofísica de Canarias, IAC, and 6 universities from the United Kingdom. The WASP observatories utilize advanced instruments, including Doppler spectroscopy, for follow-up characterization. Thanks to this technology, WASP has achieved the impressive feat of determining the masses of exoplanets, providing valuable insights into the composition of celestial bodies beyond our solar system. In the captivating journey of astronomical exploration, the observatories within the program are equipped with an impressive array, including 8 Canon 200mm f/1.8 lenses. These state-of-the-art lenses, mounted on WASP's telescopes, are easily installed on a central telescope mount developed by Optical Mechanics Incorporated. What makes these Canon lenses stand out is their extensive field of view, providing each observatory with broad sky coverage of 490 degrees per pointing through a meticulous process. They constantly screen the divine span, capturing pictures at a pace of roughly one every minute. The result of this careful observation adds up to a significant data motherload, reaching up to a stunning 100 gigabytes per night. The procedure utilized by these observatories revolves around the transit method, a complex methodology to check the brightness of every star caught in their lens. Diving deeper, these precise instruments are sensitive to detecting slight variations in brightness, indicative of large planets smoothly passing before their respective parent stars. This meticulous search has led to the identification of significant exoplanet candidates, with one standout being WASP-96b. WASP-96b, a gas giant exoplanet of considerable interest, has a mass equivalent to 0.48 times that of Jupiter. It is located at a distance of 0.453 astronomical units from its host star, WASP-96. This captivating exoplanet has captured the imagination of astronomers. The wealth of data gathered from the WASP observatories reveals key details about its orbital dynamics. For example, it completes an orbit around its star in just 3.4 days. Remarkably, WASP-96b is situated a significant 1,120 light-years from our vantage point. This discovery has not gone unnoticed by the scientific community, providing valuable insights into the existence of this distant exoplanet. The tantalizing possibility of habitability adds an extra layer of excitement to our ongoing exploration of the universe. In October 2023, the James Webb Space Telescope conducted a thorough investigation of a distant planet. According to Webb's findings, water is present in the atmosphere of this celestial body. But that's not the end of the story. James Webb also made a surprising discovery, evidence of clouds and haze in the atmosphere of WASP-96b. This revelation startled not only NASA but also the entire astronomical community, as scientists initially believed this planet to be cloud-free. Due to the high-precision cameras on Webb, our understanding of this celestial neighbor has changed. Now, let's discuss WASP-96b's orbit. It circles its star at a distance that's only a fraction of the gap between Mercury and the Sun. The discovery of water on WASP-96b supports the predictions of exoplanet enthusiasts who believe in the possibility of finding an Earth-like planet, often referred to as Earth 2.0. Beyond the thrill of this discovery, scientists are grappling with a critical question: how can water exist on a planet as hot as WASP-96b? To address this question, we need to explore the history and science of WASP-96b. This unique planet is classified as a hot Jupiter, part of a family of gas giants that orbit very close to their stars. Scientists suggest that these planets initially formed farther out in their planetary systems, where water was more abundant. Over time, gravitational interactions with other planets or their stars caused these planets, including WASP-96b, to migrate inward. This migration offers insights into the unexpected presence of water on a scorching hot planet. Orbiting close to stars has a significant impact, subjecting planets to extreme heating and tidal forces. This, in turn, causes the expansion of their atmospheres and alters their chemical composition. Take, for example, the case of WASP-96b. Researchers have observed the presence of water in its atmosphere, prompting theories suggesting the retention of original icy material during migration. Another fascinating member of the WASP exoplanet family is WASP-76b, described as a hot Jupiter's planet located in the Pisces constellation. It completes an orbit around its host star, WASP-76, in just 1.8 days, situated at a distance of 0.033 astronomical units from its star. WASP 76b dwarfs Earth due to its mass, which is about 0.92 times that of Jupiter. Although not Earth-sized, it raises speculation about the potential for human habitation in the future. Discovered on October 21, 2013, WASP 76b stands as the best-known planet in its system, boasting an estimated equilibrium temperature of 2,190 Kelvin. Much of our knowledge about this exoplanet is derived from data collected by the Hubble and Spitzer space telescopes. Through these studies, scientists have uncovered evidence of titanium oxide and a limited amount of water, shedding light on the unique characteristics of this distant celestial body. In the vast expanse of our planet's atmosphere, astronomers use advanced techniques with high-resolution spectra to observe exoplanets. Through these observations, something fascinating has unfolded. The presence of ionized elements like lithium, sodium, potassium, magnesium, calcium, manganese, and iron has been detected in the exoplanet's atmosphere. A closer examination in 2022 led to the additional discovery of barium. Scientists studying WASP 76b described it as a cloudy, predominantly gray celestial body that exhibits a warm glow. WASP 76b is not alone in the study of exoplanets. Among the successful space programs contributing to this effort is the Transiting Exoplanet Survey Satellite, TESS, a major initiative managed by NASA. TESS, a space telescope, plays a critical role in the search and study of newly identified exoplanets. Unlike its predecessor, the Kepler mission, TESS covers an area 400 times larger, using the transit method. Launched on April 18, 2018, atop a Falcon 9 launch vehicle, TESS aimed to detect approximately 1,250 transiting exoplanets orbiting specific stars. Its first light image, captured on August 17, 2018, marked the beginning of its scientific observations. TESS uses a set of wide-field cameras strategically positioned to survey an impressive 85% of the sky, enhancing our understanding of the universe and expanding the frontier of exoplanetary exploration. It has these 4 wide-angle telescopic lenses and specialized CCD sensors that help us learn a lot about planets. TESS does its work by sending data back to Earth every 2 weeks. With TESS, we can now dive deep into studying the size, mass, density, and orbits of a variety of small planets, including some rocky ones that might be in the Goldilocks zone around their host stars. What's truly exciting is that TESS makes life easier for the James Webb Space Telescope. It kind of points out the best planets for Webb to take a closer look at. While other telescopes like Kepler mainly spot large exoplanets, TESS is like a detective, finding these faint planets around distant stars. And get this, by November 2022, TESS had found 5,969 potential exoplanets. However, only 268 were confirmed, and 1,720 were dismissed as false positives. One remarkable planet TESS found is LHS 475b. It's confirmed to be a real exoplanet, orbiting a red dwarf star called LHS 475, which is about 40.7 light-years away from us here in our solar system. LHS 475, an exoplanet located in the Octans constellation, caught the interest of scientists due to its unique characteristics. Initially discovered through transit data from TESS observations, it was later confirmed by the GEST instrument. What makes LHS 475b fascinating is its similarity in size to Earth, being about 99% of Earth's diameter. However, a major difference arises in temperature, as LHS 475b is considerably hotter. If one were to visit this exoplanet, they would encounter an equilibrium temperature of 586 Kelvin. Scientists suggest that without much atmosphere, the day-side temperature could reach an estimated 748 Kelvin. Unlike many other confirmed exoplanets, LHS 475b has an exceptionally short orbit, completing one orbit around its star in just 2 days. The suspicion is that the planet is tidally locked, with one side in perpetual light and the other in eternal darkness, murkiness. LHS 475b holds an extraordinary spot in the James Webb Space Telescope's history, being the first extrasolar planet affirmed by Webb. Its span is strikingly like Earth's, and investigation from the Webb telescope uncovers it as a rocky world. Researchers were bewildered by its novel atmospheric range. Moreover, LHS 475b is nearer to its star than any planet in our solar system. Webb observed LHS 475b through 2 transits, each lasting 4.1 hours, giving a total observation time of 8.2 hours. This data contributes significantly to our understanding of this intriguing exoplanet. NASA has played a critical role in developing the James Webb Space Telescope, which stands out as the only telescope capable of observing and studying the atmospheres of Earth-sized exoplanets. After examining the transmission spectrum of LHS 475b, Webb has provided insights into the composition of the planet's atmosphere. While the data is still undergoing processing, initial findings suggest a predominantly carbon dioxide atmosphere. To refine our understanding, more precise measurements are essential to differentiate between a pure carbon dioxide atmosphere and one lacking it. Additionally, Webb has revealed that this exoplanet is somewhat warmer than Earth, sparking interest in further exploration, indicating the potential for it to serve as a habitable state for humans. Scientists anticipate more comprehensive data analysis in the coming days, which could confirm or refine these hypotheses. Detecting clouds on the planet would be a significant indicator, as it could resemble Venus with its carbon dioxide atmosphere. The unveiling of additional observational data holds the promise of providing compelling evidence and expanding our understanding of this fascinating exoplanet. The initial Earth-size exoplanet found by TESS is named HD 21749b, and this pivotal discovery was formally revealed on April 15, 2019. HD 21749b orbits an orange main sequence star called HD 21749, situated in the Reticulum constellation. Despite its significance, this star isn't visible to the naked eye due to its apparent visual magnitude of 8.143, showing its relatively faint nature. TESS deserves recognition for enlightening us about this star's unique system, including a total of 10 exoplanets. Among these, HD 21749b is identified as a potentially rocky, hot, subneptune-sized exoplanet. Conversely, HD 21749c is characterized as an Earth-sized exoplanet located at a distance of 0.08 astronomical units. HD 21749c completes its orbit around its star in 7.8 days. Although its mass cannot yet be determined with current radial velocity data, scientists estimated it to be between 1 and twice the mass of Earth, with a radius 1.1 times that of Earth. HD 21749c is often referred to as the inner planet. The star HD 21749, around which these exoplanets orbit, is smaller and cooler than our Sun, having only 0.73 times the mass of Earth. It exhibits an effective temperature of 4,640 Kelvin. TESS telescope data indicates that the metallicity of HD 21749 is roughly equivalent to the Sun's metallicity. TESS has not only uncovered Earth-sized exoplanets but has also brought larger, potentially habitable planets into the spotlight. TOI 700d, belonging to this category, is a near-Earth-sized exoplanet believed to be a rocky world orbiting within this intriguing celestial system. This is a red dwarf star located roughly 101.4 light-years from Earth in the constellation of Dorado. TOI 700d, this exoplanet, is situated in the habitable zone, marking a significant discovery by the transiting Exoplanet Survey satellite. TESS identified it as the first Earth-sized exoplanet in this zone. TOI 700d orbits its star at a distance of 0.163 astronomical units, completing its orbit in a short 37.4 days. Examining data from the TESS telescope, researchers have found that TOI 700d receives about 86% of the energy Earth receives from the Sun. Since its discovery in January 2020, scientists have continually revealed new insights about this fascinating planet. Despite the progress, there are still gaps in our knowledge, such as the unknown mass of TOI 700d. Although estimates suggest it is around 1.72 times the mass of Earth, an exact measurement has yet to be acquired. The average temperature on TOI 700d is calculated to be about 268.2 Kelvin. However, there's a potential concern of a possible runaway greenhouse effect. This uncertainty underscores the need for further investigation, with the James Webb Telescope poised as a vital tool for such endeavors. Delving into the realm of Earth-sized exoplanets, April 17, 2014 holds significance as the day Kepler 186f was discovered. This green exoplanet orbits the red dwarf star Kepler 186, located some 558 light-years away in the constellation of Cygnus. Kepler 186f's orbit, at a distance of around 0.43 astronomical units, takes approximately 130 days to complete. With a mass around 1.44 times that of Earth and a radius roughly 1.17 times that of our home planet, Kepler 186f stands out as a promising candidate for potential life. The Kepler telescope, using the transit method, revealed the presence of Kepler 186f as the first planet with an Earth-like radius found within the habitable zone of another star. The Kepler 186 system boasts 5 known planets, and the star itself has an apparent magnitude of 14.62. Remarkably, Kepler 186 is relatively young at around 4 billion years old, making it 600 million years younger than the Sun. Unfortunately, the vast distance of this exoplanet hinders detailed study by the James Webb Telescope. Despite the limitations of Webb, the development of more advanced telescopes will enhance our understanding of planets like K2-18b. Recently, Webb made a significant discovery about K2-18b, an exoplanet orbiting the red dwarf star K2-18, located 124 light-years away. Initially discovered by the Kepler telescope in 2015, Webb identified carbon dioxide and methane in its atmosphere, suggesting the possibility of oceans and a hydrogen-rich environment. K2-18b, 8 times the mass of Earth, orbits its star in just 33 days within the habitable zone, receiving a similar amount of starlight as Earth. Often referred to as a mini-Neptune, it could either be rocky with a thick envelope or have a Neptune-like composition. While astronomers believe it might be tidally locked with an equilibrium temperature of 250 Kelvin, tidal heating seems unlikely. Observations from the Hubble Space Telescope reveal that water makes up 0.7 to 1.6% of the atmosphere, primarily consisting of hydrogen with minimal ammonia. K2-18b serves as a significant case study for exoplanet research, offering insights into the potential for life. As we continue studying, we hope to unravel more about this captivating exoplanet in the days to come. Thank you for tuning in today. Keep an eye out for our upcoming videos. Stay connected, and make sure to hit that subscribe button and the bell icon so you never miss an update. Until next time, take care.